I'm Ravi Ravichandran from Clemson University. I teach geotechnical engineering at junior level classes and senior level design classes and also graduate level classes. I cover earth slope containing structures, design and other geotechnical system design. My research primarily on geotechnical earthquake engineering using computational methods. So we came here Sunday. We had a workshop Sunday afternoon. That was kind of eye-opening to me because I'm a geotech, but I've been working above the ground, although I do like a ground motion and prediction and site response analysis. So underground has always been an interest to me. So when I attended the workshop and Professor Mooney and other practicing engineers talk about the underground, the importance and the design and the challenges, that was amazing. So since then, I have been checking every single presentation. So I have been moving to different rooms to attend very interesting presentations. The TBM is amazing to me to see how it actually cuts, boring and a very large diameter hole, and it goes through rocks and soils below the groundwater for miles and miles. So this is kind of amazing to me. I'm going to have a graduate student kind of working in this area, and also I'm going to incorporate underground design, construction and other issues in my classes I teach. I never thought of kind of getting into this in detail. This is purely geotech and structures. Actually, there is an interaction going on between geotech and structures. And after attending one presentation like a few minutes ago, I realized it's not just geotech and structures, it's actually geotech, structures and the fluid mechanics also come in the picture anytime you have water flowing through the pipes. So this is like an interdisciplinary within civil, so it's a great thing. I think the smart mind should get into it to come up with efficient and effective solutions. Yes, absolutely. This is very interesting for me. A lot of computational modeling going on, and at the same time there are a lot of issues. The professors can actually help and get involved. One thing I was telling to Samar a few minutes ago, some of the things they were finding solutions, particularly the subsea, subsurface exploration. We might take a long time if you are looking into the research lab or maybe a graduate student working on it, but practicing engineers, they needed to come up with the best solution within a short period of time. I think getting involved, interacting with the practicing engineers will help them in research, and also both ways. They can help the practicing engineers, at the same time the practicing engineers can help the professors kind of advance the technology and also come up with the better solutions. One thing it's amazing to me to see here, other conferences which I usually attend, I would say 90 to 95% of them are professors and graduate students. Here, I would say it's opposite, 90 to 95% practicing engineers. So me being here, I see completely different ways of approaching a problem. So this is very practical to me. I think that will help me because I'm not just doing research there, I'm teaching 50 to 60 students in every class. So I'm taking my practicing experience from this type of conference to my classroom. So that's going to benefit my students. The professors, the organizers have offered to kind of constantly mentor us and provide everything we need. For example, we can easily call somebody and say that, hey, I need a speaker in my class from underground construction technology related things. They are going to help us, and also field visits. If there is anything happening around, let's say Clemson or any other places, they'll be happy to organize and have our students. So these are great things. I'm very happy to have that kind of support so that I can introduce this concept to my students.